Hello, I'm Jivita Christie, and in this video, I'm going to start a new lecture series for data analysis and visualization. Here, you will be studying how you can analyze data to find more meaning in it and to also conclude and summarize the data. And once you've done that, you'll understand how you can visualize that data. That is, you'll make different types of graphs and charts using that data in order to better show meaning in that data. So that is what this whole subject is about. And you're going to study all these things, and you'll study even some real world problems and how to analyze that type of data and how to visualize it. But before we begin, what I'm going to explain to you right here in this video is a basic introduction to statistics, because without statistics, we cannot analyze the data. That is a stepping stone and a pillar in order to understand data analysis and visualization. So let's begin with an introduction to statistics, which will continue in the next couple of videos. So first we are going to see what statistics actually is. Statistics is used to collect data, it is used to summarize data, and it is used to interpret data. So to collect means gathering the data because it's not always readily available. Sometimes to solve a problem, you have to get the data. So once you collect that data, once you gather that data, then you can analyze it. And in order to be able to collect data, you'll study some techniques of how you can gather data and how you can gather data in such a way that it has more meaning and that it is not biased towards one opinion or the other. And once you've collected data, you can summarize the data. By summarizing, I mean finding meaning in that data. And for that, suppose you have a large amount of data, and you cannot really understand that data yet because it is so big. But when you summarize it, by using some techniques, when you summarize it, then you basically shorten it. So to summarize is when you have something large and then you convert it into something smaller so that you can easily understand it. So that is what summarize means. And a very good example of summarization would be just to apply mean, median, or mode, which are very basic statistic measures, which I'm sure you must have studied in school. So if I'm given, say, um, about 10,000 numbers, and those numbers depict the ages of different people. And let's say these are the people who probably visit a theater to watch a movie. So if I'm given the ages of such people and so many people, and I have to decide which is the which is the age group that visits the theaters the most. So because I have 10,000 numbers, I cannot make sense of it. But if I were to apply a mean, I were to take average of those numbers, then I get some summary and some information. And if I were to apply a median or mode function, I can get to know more about the data. I can understand the data now. So you're going to study about some other such measures also, not just mean, median, and mode, but some other measures that might help you to summarize your data. And once your data is summarized, the next step is to interpret. And interpretation is quite easy once you have summarized the data. So interpretation of data is where you will try to understand the data and find meaning in the data after summarizing the data. And then once you've done that, you need to visualize. So for visualization, we are going to use certain techniques, but statistics is mainly for analysis of data. Let's understand some terms related to statistics. The first term is population. So population could be anything. It could be opinions of the population of adults about the death penalty. So here I'm talking about people, opinions of people about death penalty. And those opinions of the population, those people will form my population for analysis. Population is not limited to just human beings. It could be a population of mice that react to a certain chemical. So if there is some medicine or a vaccine or some sort of a chemical that has been discovered or invented, and that needs to be tested before it is given to human beings. So at that time, it is usually tried on animals first. So if this type of chemical is tested on mice, then what is the reaction? So in this case, I'm not studying human beings. I'm trying to find interesting patterns and reactions of mice to this particular chemical. So my population in this case would be a population of mice. Population could also be some inanimate object. It's not necessarily something that can move around. For example, houses. So I could be having a population of one-bedroom apartments in a certain city, and maybe I'm trying to study their prices, how they vary, and what features are available in the houses. So that is also population. Now, population is huge because, as you can see here, it is something very large. It is a large thing because if I consider all if I consider, let's say, human beings, and I'm taking their opinion about the death penalty, I cannot basically go around and ask everybody to give me an opinion because there are so many people. And that's why we cannot use the whole population, but we rather use a sample of the population. And that's what you can see here. There is a sample taken from the population. So the yellow part that you see is the data, because we do not require everybody's opinion. We require the opinion of some people, and these few people are selected in such a way that they are not that all the people are not biased one way or the other. Sometimes it might happen that there are people who are favoring the death penalty in a certain city, and you are trying to take your sample from just that city, then your analysis is going to be biased. And also sometimes it might be that there are people who are of a certain cultural background or ethnicity, and you are trying to get your sample from among such people. And those people of that culture, they do not support death penalty. And you've taken your sample, your entire sample, from among those people. So in that case, again, your data is going to be biased towards one opinion. So it's very important to take a sample that is completely unbiased, and you'll study such techniques later on. The next thing you need to know is exploratory data analysis. So exploratory data analysis is something that you perform on the sample. Once you've got the sample, you're going to analyze the sample. You're going to apply different statistical measures to that sample to in order to conclude it or summarize it so that you can understand it better. And then the next thing we deal with is probability. So probability allows you to draw conclusions about the population based on the data collected. And if you do not get all these steps right now, don't worry. In a little bit later, I'm going to explain this to you with a real world example. So probability allows you to draw conclusions. Once you have summarized the data and you apply probability, you'll come to know what kind of conclusion you can draw. So if you're talking about the death penalty, then what is the probability of people supporting the death penalty and what is the probability of people not supporting the death penalty. So these types of conclusions can be drawn with the use of probability. Next, we have inference. Inference is all about using what we've discovered about a sample to draw conclusions about a population. Now, this is something very important because you have a sample data, because you cannot analyze the whole population, which is so huge. That's why you took a sample. You analyzed the sample by performing exploratory data analysis, and you even applied probability measures on it and calculated things. But that is an opinion of a sample. What about the opinion of the population? To find that, you would be using inference. So based on your results for that sample data, you will try to predict now what could be the result with the whole population without having to analyze the whole population. So that is what inference means. Now we're going to go through a very interesting example explaining all these steps. So this is a real example of real data that was collected. And so I'm going to read it out to you. At the end of April 2005, a poll was conducted, which was conducted by ABC News and the Washington Post, for the purpose of learning the opinions of US adults about the death penalty. And I'm sure you know what death penalty is. So it is a punishment given to criminals wherein instead of putting them in prison or giving them a life sentence, they are actually given a death sentence wherein they are killed. So this is an opinion, a poll conducted by ABC News and Washington Post to understand what US adults think about the death penalty, whether they favor it or they do not favor it. Now, number one is the first step in our statistical process is to produce the data. So to do that, a representative sample of 1,082 US adults was chosen because we cannot actually go and ask every US adult. And even if we could, that much data, to analyze that much data would be a tiresome task. So you need a sample, and that's why a sample of 1,082 US adults was taken, and then each adult of this 1,082 was asked whether he or she favored or opposed the death penalty. So that's our data, it is produced. The next step is to perform exploratory data analysis. So in this, the collected data was then summarized. So by summarization, I mean either calculating the average or finding out how many people favor, how many people do not favor. So some sort of accounting is done. And it was found that out of 1,082, 65% of adults favored the death penalty for persons convicted of murder. So that is the result of the analysis. And then we proceed to the next step, which is probability and inference. So now based on this result, which is 65% people favoring the death penalty, and our knowledge of probability, it was concluded with 95% confidence that the percentage of those who favor the death penalty in the population is within 3% of what was obtained in the sample, which means it is between 62 and 68%. And if you don't get it, I'm going to explain it to you now. So this is something very simple. What it means is we found out that the sample, out of the sample, 65% people, they favor the death penalty. But after that, by calculating the probability and inference, we found out that based on this summarization, we can tell, and we are 95% confident about this, that the whole population, if we were to ask even more adults, or if we were to ask everybody in US about the death penalty, then about 62 to 68% of people will favor the death penalty based on our summary of the sample. So based on that 65%, we can conclude with 95% confidence that 62 to 68% of US adults would favor the death penalty. And it is written over there that it is within 3%. 3% essentially means that 65 is our result. So 65 minus 3 or plus 3, which gives us the range 62 and 68. So that is the range in which you can have this type of a conclusion. So this is the big picture. You can see here in the big picture how the whole process of statistics works. And with this, you can understand how much percentage of probability was calculated and what is the summary. So this is the whole process. This is the same diagram that I showed you earlier, but this time you can see little notes below written in blue to show you, to better explain to you the example that we just saw about the death penalty. So this is what statistics is all about. And in the upcoming videos, I'm going to explain to you more about statistics and different steps involved in the process so you can understand your data better. So I'll see you in the next video. Thank you for watching.